Hello, welcome everybody. I'm glad to be here for this talk on towards the rebirth of data science. Before, I would like to know a bit more my audience. Who is or consider himself as a data scientist here? Okay, a few of you. Who is already, working or playing, let's say, with distributed systems? Cool, awesome. And both of them doing machine learning or whatever on distributed systems? A few, okay, that's why you are here then. Okay, so about this talk, first, so it's gonna be a talk that it should have been given by me and my buddy Xavier Tordoir, but actually he's in Mountain View giving the talk at H2 World on machine learning on genomics, so he couldn't attend it with me. So I'm gonna give it myself alone and sad. So, so my name is Nutsab. I don't have any names. No, just kidding. Anyway, so the outline for today. First, I would like to introduce a bit what was, or still a bit, is data science pipeline or product. What changed since then? Finally, what is, in my opinion, or in the opinion of Data Fellas, a distributed data system, data science system. What are the challenges for this kind of system, and what we want to do to go beyond that, so to solve the challenges and to move forwards. So Data Fellas is a company that I created with Xavier 6 months ago, so pretty new. Myself, the gorilla, and the Petrella, Nutsap. So I'm basically a mathematician. I did a lot of geospatial in my work time. I did plenty of other stuff during my spare time. I created the Spark notebook. By the way, who knows Spark here? Great. Who knows the Spark notebook? Ah, still a few. So it's a tool that I created in order to play interactively with Spark and distributed systems. I'm a Spark and Scala trainer, and I did machine learning since my studies, by the way. Xavier is a physicist, bioinformatician, PhD in physics, actually. Distributed computing, we does that all the time since 2012, I think. He's a Scala and a Perlist guy. He also a Spark trainer with TypeSafe. Machine learning is the core of our art. Right, so first let's start with the legacy stuff. So what is data science pipeline / product? So everything, sadly enough, starts with sampling. So when we deal with data, when we start a new project, we start always by sampling the data. And I will get back to that for why we are sampling data. So we get the data, we clean that. So in sampling, I consider also the cleaning phase, because it has to be done, of course, because all the data are always crappy. And you know that shit in, shit out, so we try to clean the shit first. So the sampling is this phase, right? So when we have a reasonable amount of data, we can start modeling. So what does that mean, modeling, finally? So it's not finding rules that can describe the word. It's more trying to find the best function family and then the best function instance that can, in given some data, represent the generative function. So this is what exactly is modeling when we talk about machine learning, for instance. So we have modeled using the data, and now we have to tune it. It's a back and forth process, of course. We tune, we model, we tune, we model. And when it's done, we create a report. We created a report. What can be a report? It can be a PDF, it can be a static web page, it can be something that has been generated based on the data that we had initially sampled. And when we have this report, we pack it into a mail or a package or whatever, and we send it to some people that can take some action based on the data, on the function that we created, or the result that we came out with. So, and this guy, who is mainly the knowledge guy, so he knows the domain. So he has, the key to act on the system, to maybe to solve the problem that you have discovered, or maybe to tweak it. So only at that time, this guy is able to take a decision. However, this decision is only taken on static results. So it only take the report, analyze it, maybe sorry, charts, tables, and then it takes some actions. However, during this process, static results has been generated, and a lot of information has been completely lost. In translation, because the data scientist has to explain what the report is all about, so he has to dump his mind somewhere, right? And also, we have sampled the data, and during the sampling, afterwards, while we model, we should have, or generally we have to create the features. So we have to select features, or we combine them. So that means that again we lose a bit of variability of the universe that we are dealing with. So there are a lot of information that has been lost. And also, it really sounds like waterfall, or I would say water fail, because at some point when the guy there, the interpreter, has to take an action, right? There is a high chance that the universe has changed since then. Right? And if you want to react on that, you have to come back to the sources, maybe, on the model. You don't even know, actually, where you have to come back. Because you had, again, you have lost a lot of information backwards. And it'll really look like ETL, finally, right? You extract, transform, load, which is the kind of thing that we want to avoid these days. So this is what I call legacy data science pipeline. And there is a bad phase there, sampling. Why do we have to sample generally? We have to sample for two main reasons. The first is pretty obvious. First, we had to deal with data on money machines, unless you are doing HPC, but how many of you guys have dealt with HPC here? Yeah, okay, that's fine, 0. So generally we had money machines, right? And money machine means we have a limit on the CPU that we can use, so it's a very constraint on the computation that we can run, and a limit, a constraint on memory. So we cannot go beyond that, so we have to cope with that. That means that if we cannot load the whole bunch of data that we have in memory, or we cannot process it efficiently in streaming manner, right? On a money machine, we cannot go to the market. So you have to be faster. So you have to be smarter, of course, because there are a lot of sampling methods. They are very, very smart. But still, these are sampling. Another reason why we do have to sample is to, this bias variance problem that we have in data science. So generally what we have the full universe. We have a very small fraction of the data of this universe. And in order to not overfit or underfit the data, so we want to generate more version of the data. So we can have different version of the function that we are generating to represent the word, and then we can aggregate at the end. So this is why we have to sample. But it's bad. Still, it's bad. Why? Because our world changes. So I'm not gonna be very disruptive here. Actually, this is the fact that we are, hearing for 2 years now about big data, whatever it means. So it's like, well, yeah, okay, now we have data that gets bigger and bigger and bigger. Or in my side, I would say the number of sources are increasing. It is increasing, actually. So we have more and more sources, more services that are popping up everywhere. We just had a talk about startup. Actually, if you go to San Francisco, there is a startup on data science every day. So that means new sources, new ways to deal with the data. And when I say data science, I mean just also not really doing data science, but really generating data only. So yeah, this is a problem, or this is an advantage that we have to take in consideration. The second thing is, of course, that the data is getting faster and faster. One example is simply, you can now watch, Netflix on your smartphone while waiting the train or the plane at the airport. It's like, remember 15 years ago in Devoxx, when we had to wait for 3 or 4 days to get a fracking CD that we had to share with buddies? I mean, it's done. I mean, man, now we just have to light on your smartphone and you can watch whatever movie you want to. And it's very awesome. So, and we also have to take this into account. That means that some consequences, we can detect some consequences on the data science pipeline that we are used to use. First, sampling is very bad, as I said already. First, I mean, it's more or less impossible now to do it, to do a good sampling. Or maybe it's not even necessary anymore. Why? First, it's very hard to do sampling on big data or fast data because there is a high chance that the sample in itself is going to be big. So if the problem was that you cannot cope with your machine, right, with an amount of data, right, sampling doesn't work as well. Or you have to generate so many samples that you will hit the bound of the CPU. About cross-validations. Is that still relevant? Actually, the problem that we want to solve with cross-validations, with scaffolding or whatever, we want to avoid to have overfitting on the data that we just saw, right? So a small portion. However, now that we have so many gigs of data that we can process, right? It's not necessary anymore in some sense to do cross-validation. If we are able to take into account the full data set, right, we can be almost sure, not pretty sure, but almost sure that we have enough variability in our data set so that we can just have a test data, a training data set and a validation data set, and that's it. Which can be 2 terabytes and 1 terabyte, by the way, but still. Reports. So there, yeah, of course, and sampling means that it's ephemeral, right? The data is coming faster. That means that the sample that you have created at time t0, at time 1 is not good enough. The schema have changed, maybe. The word has changed. Some new events has occurred in the news, and then everything is screwed. Let's think about maybe trading systems. I mean, those guys cannot cope with sampling anymore. So it's very ephemeral. Reports, same thing. A report is based on the sample that we just created at first. So that means that, of course, it's very quick deprecated. So you can really take actions based on that. That's what I mean by that. You cannot really take action on that. And it's also a restricted view. That means that you have what? 2 tables, 4 charts, that's it? And you had 2 terabytes initially, maybe? It's a bit dumb. Right, so other consequences is that the guy who was very important at the end, the guy that was able to interpret, the guy that knows the characteristic intrinsically of the domain, you know, he's living in the domain, this guy has to cope with charts and tables that are getting bigger and faster. So this guy has to what? Look at the screen the whole day and trying to detect live what's going on? That doesn't work like that. I mean, we need to be smarter than that, more clever than that, right? So how to work around this problem? So we have to work around the problem that this guy cannot be in front of his computer, or maybe he won't see the problem, because if it happens every 2 milliseconds, he just won't see it. So we need to be able to work around that. And also, it takes a bit of time for him to read that. I mean, it can take days before he come up with a solution, and it's way too slow to get an array efficient enough to validate the system that you want to put in place. Okay, so how to work around these problems? So there are several needs actually that we can depict in the world of today. So first, maybe we need an analytic system and not descriptive charts or stats. Something that can tell you, hey, there's nothing going wrong there. And for that, of course, we need to have more accurate results. If we have a lot of, false positive, for instance, it can be very, very boring for the guy to use your tool, so he's gonna deprecate it himself. And the reverse is the same if you have too many false negative. So you need to very take care on the accuracy of models. And to be able to do that, so you need most probably to have more harder or just more models that you need to aggregate at the end, right? Like deep learning. So there is a lot of buzz around deep learning. And this is what Xavier was talking about in Mountain View, by the way. So this is something that you need because actually you have so many parameters that you can take into account with the amount of data that you will deal with, that something like deep learning can make sense. And also, we have the resources now available to deal with this kind of very resource-intensive models. And of course, if we do that with a few data, it's not going to work. It's not gonna work. You will have not enough variation in the data that you had to be able to do something relevant for the future and robust with changes. So that means you need more data. And of course, as I said, faster data, that means that you need to have a constant flow of the data. So you need to be reactive on that. So the data should be taken into account while they are arriving, not today, not tomorrow, or maybe a week after. And finally, online interaction. So the guy at the end, the interpreter, is still really relevant, meaning this guy has still to be there because he still has the full knowledge. Even though you try to dump a part of his knowledge in the model, right, you still need this guy to be able to take the right action because he's the only guy that can really interpret in the system what it has to do. Of course, if you have a direct feedback from the action to the system, so you can detect what the action has, the implication and the impact of the action on the system. That means that the system can also learn what action can be done in which situation, right? So that means that you could also help him. This is, yeah, direct feedback, something like recurrent network or just feedback systems. So in our opinion, in data fairness, we just need distributed systems. To do that, you cannot cope with them on a machine. We cannot cope even with HPC. You can do that with SPC, but there are a lot of problems that with SPC that we talked about on Monday if you came to our talk on machine learning here. So we need distributed systems, of course. But what does that mean, distributed systems and data science? What is a distributed data science, finally? Or system, platform, product, whatever. So you want to start an analysis, right? And you have this distributed system in hand. So first, most probably you want to create a cluster for you. Yeah, but there is a big cluster, and in my opinion, it's very dumb to say, yeah, you can take whatever you want. Just use a cluster. There are 100 machines, take as much as you want. It doesn't work. I mean, if you have 5 data scientists, they're gonna fight for the resources, and it's gonna be not very efficient. So you want to maybe create a smaller cluster in the cluster, right? So you want to dedicate some resources to these guys. So this is the very first phase that you want to do in your pipeline. Next, you will have to find resources in sources. Of course, it's not different than before. You still had to do that. But now you have so many sources available that your work and your task is harder now. You have to find across all these sources available, and it can be very tough, and also trying to see if they are relevant for your data science problem that you are tackling. So, and that means, you have to understand the context of the data that you just found, the content, see what quality, its quality, the semantic of the different rows and the structure. It can be very tough. Afterwards, you need to connect these sources to your system, of course. That means that you need to know the structure, right? So you need to know how this information is structured on the disk or in the database or whatsoever in order to get enough information in order to be able to process it and to model it afterwards. It's not like, yeah, it's a black box, yeah, I put all the data there and I just wait for some magic to happen. No, you need to know the structure, you need to know the data from the core. And this is very helpful to have the schema and the types, of course. If you have the schema and the types, it's gonna be way easier for you. Otherwise, you have to have these heuristics that try to find if it's enumerations, if it's double, if it's a dummy variable or no. I mean, it's completely crappy. So you need to have this kind of data books or types and schema if possible. Next phase, you need to create a pipeline, a distributed data pipeline, which is hard. I mean, it's hard because you cannot really use the tool that has been shaped so far. You cannot really use MATLAB, scikit-learn, all these tools that you were used to use to do this kind of stuff. Now it's just deprecated. You cannot reuse them because actually your data is completely spread around. Data is just split it all over the place. It has different structure. It is chunked. It is compacted. So you cannot really use this way. You have to. Otherwise, you have to collect all the data locally and process your data. It's gonna screw your machine, right? So you have to have models that have been thought in such a way that they can run in a partition manner. So you have to distribute the functions, then collect only the result at the end when the process has been run on the system, on all the nodes, on the cluster. So it has to do that, and it can be a tough task, of course, and that will require a lot of tuning the accuracy of your model, right? So you have to, you have a target, you need to reach this target, and you need to reach this target within certain time bounds. So it's about performances of your model. So you have to tune that back and forth. You need to, check this model, maybe tune a bit the hyperparameters. So, and then you need to maybe add one node or reduce the amount of memory dedicated to the nodes and increase the number of nodes. No, it's gonna be quite tough as well to do, right? But you have to do that, otherwise you might lose a lot of money in running systems that are too big for your system, and then you reduce the number of models you can run in your system at the same time. So it's very important to think about. A new thing is writing the result to sinks. This is something that wasn't really there in the legacy pipeline. Now you need to write this information into somewhere, not in a report, right? Actually, the thing is that your data gets bigger, your data gets faster. That means that, the results themselves will be big or fast. You cannot squeeze them into a report. It's not gonna work, right? Or otherwise, you were gonna fall back in the same problems in static results or deprecated results very fast, and so on and so forth. So you need to write this information back to something that you can consume afterwards. So you have to consume them. These results are also big data, fast data. So you need to access them. So they are maybe in HDFS, Cassandra, whatsoever. Now you need to access them. That means that you need to have something like services. So we do services to access data since '90s, or maybe even before with SO and so forth. So these are still relevant. Now we have, there were a lot of talks about microservices, and it makes sense even there with big data between codes, because big data for me is just a dumb word. I prefer to talk about distributed systems. So microservices is still relevant. Why? Because actually you can create a kind of microservices with a few functions that can access the result of a model of a pipeline that has run on a system, or still running on a system, by the way. The user access is the other side of the report, right? Is you have services, so now you have to have another layer outside that can consume this information. So that means that you need to provide a way to access this information, so using services, using relevant technologies that can scale, because you don't want to have your users of your services using the same cluster as your processes. Because if at some point you have 10,000 users where you had only 1,000 at some point in time, you don't want to scale your computing cluster, right? You just want to scale your services. That means that this thing has to be targeted correctly. So that means that the information sent to this user access has to be very condensed, at least binary, right? Schema-oriented if possible. And then you can have connectors to other third parties, like other services or dashboards or whatsoever. You don't want to provide PDF with tables and schemas and charts, of course. You don't want to do that. With terabytes of data that are changing every now and then. So that means that you can create other pipelines based on the results of your previous model or the services themselves. This is a resume of a distributed data science pipeline, I would say. However, what about productivity? Man, creating a cluster, you need some hubs guy. That might require so many things, like maybe Mesos. So it's actually it's a coincidence. So Mesos, you might have to use HDFS. Install an HDFS, install Tachyon. There is a talk about Tachyon at 3 o'clock. I recommend to attend it. Spark, Cassandra, Elasticsearch, Kafka, whatever. So you might require all of those tools to be installed over there in order for you to process correctly the information that you need. Then you need to find the available data. Okay, so you need a data engineer. That will require all the stuff like, again, Tachyon, Cassandra, Elasticsearch, HDFS. Connect to the sources, Now it's a combination of the ops guy, that knows where are the machines, and a data engineer that knows how to connect to these tools in the machines. So you might need, Spark, Cassandra, Akka, HDFS, Avro, Thrift, please, JSON if you already have to do that. But please consider binary and schema-oriented formats. And finally, you can start your pipeline. Only back then, we have already a messed up slide there. And then there you have Spark. You can use sparkling water from H2O. You can use all the toolkits like Dell at Intel, or SystemML from IBM, or deep learning for J, SparkML from SkyMind, or whatever. So you have plenty of different options right now. And we at DataFellas, we are creating another deep learning library with Stanford and with Nitro right now. So it's going to be yet another one. So you have plenty of options. So that means that you need to, understand the models. You need to understand the code correctly. So this is something that is part of the pipeline. And finally, you need to tune the accuracy. So you back with some methods and Spark and sparkling waters, because this is mainly tuning parameters. Then you need to tune the performances. So a scientific guy needs to deal with an ops guy in order to add machines. Maybe for Kafka, I need to tune the memory for my Cassandra nodes, or increase my HDFS space. Add new data nodes, whatever. So this is how you want to process this phase of tuning the performances. Writing results to sinks. Okay, again, you might want to store them in HDFS, something which is really reliable, really resilient, and replicated. So Spark can also, it will be used, for instance, to store the data, but you will need some nodes, of course, to run it, some HDFS, again, to get the data, Elasticsearch, maybe, if you want to index some stuff, Kafka, if you want to write it back then. There. The access layer, the access layer, which is just the accepting the different services. You can run, ICA, Spray, Tycoon. You need methods to scale it up and down. You can use Vertex, whatever, anything that works. Node.js, no, just kidding. User access. User access, it's the easiest path for us because it is not our role to do it. It's just a connector to Tableau, for instance, using the different binary format, to ClickView, maybe just D3 dashboards, or just services as well. You can do that like this. But not only that, not only the tools are very important. So you had there like a very messed up, slide. It's just unreadable right now. It's so many things. Of course, there are a lot of stuff that are recurring everywhere, but still, a lot of stuff to learn, man, right? How to use them, how to install them, how to maintain them, right? Not only that, you have a problem because all those guys, all those web engineer, data engineer, ops guy, scientific, are talking a different language. Some are talking Python, Vagrant, Chef, the others Java, Scala, maybe, I don't know, Ruby, whatever. Actually, all those guys can talk a different language. So you may want to try to choose one language, but then you have to choose correctly, otherwise you might upset some people, right? But still, I recommend to choose one single language. Otherwise, you will get lost in translation again. So you will have to, I'm going to write my model in Python because, I have dual tools. I can use scikit-learn, sample it. Yeah, already done. Then I can create my model. Then we can run it in the system. Okay, do that. And then the data engineer has to take the model, understand it, port it into Java or Scala, and run it in production. So it's fucking error prone, right? You don't want to do that. You want to try to stick with one single pivot language for the main and the important phases of your pipeline. So this is all about. And I forgot some languages, of course, on purpose to not screw again more the slide. And we already did, by the way. So, right. Productivity, maybe a recap. So now, with that in mind, and hence, we can understand that we have a longer production line, right? it's going to be quite tough to be very agile, lean, and target the market very, very soon. We have more constraints, not only the resources on the machines, but also the time that we have to spend in maybe communicating between all of us. More people, more with different skills, very important to not overlook that. Otherwise, we are going to be kicked sooner. It's very tough to deal with that kind of thing. I mean, for a manager, I mean, it's very tough, but it's like that unless you want to solve it beforehand. So you don't want to overlook it, so you want to solve it beforehand. So in some sense, what do we have to do? Where do we have to be productive? I mean, we have to come up with fast results, but still very accurate. Otherwise, our alerting system is going to be very interesting to use. It's going to be completely skewed, and then nobody will use it. So you need to be very reactive, and how you will deliver your models and your results, right? So you need to be very picky at that, and the responsibility to external events. So that means if there is a new stuff that arrives in the world, so you want to be able to take it into account quickly. So you don't want to have, hey man, let's get back to create a cluster and then check new sources of information. We're gonna take again 2 weeks or 3 weeks to do that, and then finally we're screwed because the client is gone. So we have to deal with that when we have team fight. And the team fight is seen like this by members of the team, right? So it's like superhero that fight for the good, but they are all fighting all together and to each other. So they are fighting the good versus the good, the bad versus the bad. They don't even know what they do, right? And this is how it's seen by the members, because they are just fighting for languages, for resources, and for something like this. And this is just money which is spent very sadly for nothing. So you have team fight like this. And this is seen by the managers. Looks like two gentlemen cats that are fighting from far, and while it's still not productive because, there is nothing happening out there. And it's very, very, very sad, because nothing happened at that time. The guy on top, the employers, they just see puppy fights. Pussies fights. What the hell is going on there? This is just fight or playing. I cannot even understand if they are just playing or just having fun or they are very upset about what is happening right now. Of course, a slide deck has to have cat, of course, in there. Otherwise, it doesn't work in Devoxx, actually. Right, and finally, the customers. Those guys, what the heck? I don't have anything. It's been a month, man. I'm losing money right now. I don't want to have just one slice of fish. Come on. So this is something that we don't have to overlook, because this is just spending time for nothing. So this is something that we have to take care beforehand. So that's why at Petrella we think a bit differently. We want to be interactive and reactivity. Interactivity and reactivity has been our first target. So we want to tighten and to shorten the frontiers and the time spent between teams and between members of the team, right? So that's why we have this Spark notebook that I talked initially, and which allows people to deal with their system interactively, directly. So you just have a web page with cells. You type some code, you hit enter, and you run the process on a full cluster of 200 nodes, if you like. Actually, we ramp until 700 easily. So you have this interactivity, and then around that we build share. And this is a concrete example of a distributed data science which can solve a part of the problem. Because it's actually an integrated reactivity, not only at the machine learning phase, but also within the different steps required into this phases. So what we do, so we go from analysis in notebook. So okay, I'm starting my analysis. I can run my model. I can use my data. Then I want to have my project generated in a system. So we have a project generator that goes from a notebook to the system. Then we have something that can generate the services directly because we have the information. is going to be binary format, because I'm a binary freak and a type freak. And we put that into distribution system. We have all the types, we have a binary format, so we can have rendering there, not before, just there, right? Because we have the services, we can hit them, and we can render whatever we like. In Tableau, again, ClickView, whatsoever. This all information, we want to index them into a discovery system that can be accessed from the notebook again, where you can search for data, right? And everything is generated, I mean, stops, right? So we cannot do the work for you guys. I mean, at least we generate all the boilerplates for you. But wait, let's take a concrete example, if you like. On Tuesday, with some buddies from Data Stacks, Mesosphere, and TypeSafe, we had this hands-on on going from big data to microservices. And for that, we use many tools in 3 hours. Adam, Aka, Cassandra, DSOS, sorry, Michael, DSOS, Spark, and the Spark Notebook. In 3 hours, we were able to tighten all these tools to streamline them into a production line that went from genomics data, because we do a lot of genomics in DataFedas, genomics data towards a microservices deployed as an Aka on the JVM. Right, and if you want to take a look at that, there is a Docker image that you can just pull and take a look at it. There is also a GitHub that we will publish the URL soon, where there is plenty of information. Okay, the example is, so we take some data on the file system. So this is a Docker instance, so it's very limited. So we take some data from the file system, we process it with Spark, we create a data frame. A data frame has a schema, it has a notion of the data structure, okay? And then we store it as a Parquet, locally or an HDFS if we like, right? This is the first step. So we take the raw data, the very crappy data from the sequencer, okay? We process it, variants, boom, into something structured that we store in the file system. Then we want to take this data, this is structured, prepared, right? And we put it into Cassandra. To do that, we create a schema, and then we read the data in Parquet, which is highly optimized for distributed systems, and then we process it slyly, compute some statistics, and we dump it into Cassandra. Like this. Again, from the notebook. Then, you want to have a service. So you can create some services like Julian did with Aka HTTP. So you have the data. You can create maybe two endpoints that will render. Sadly, we did JSON, by the way. You can render in JSON. So we have this, mechanism that will take the data from Cassandra, shape it, create a model out to it, and then render it into JSON and produce an endpoint on listening on the 1111. So this is the service part that is serving the computation on the genomics information. Then from the notebook, you can connect to it. And as you can see, there is a problem because in my REST client, I have to define myself the case class, the class that defines the structure, which is very bad because this information should be distributed as well with the data. I mean, the schema should be given to the user, right? So here, because I know the structure, I can do it. Otherwise, it's just a JSON, right? I don't have much information. Here, I know it, so I can define it. I can define the reader and so on and so forth, and then I can define my my client. Right, so I have my service, my client, my processing jobs, and so on and so forth. But what do we need now? So, okay, we reach a point where we have a complete pipeline, but what can you do? Actually, we need to deploy. So there's just web page right now. It's just process, define, just code, right? So we need to deploy these things. Then we need to connect the dots. We had two different notebooks that one just generated the prepared version of the data. The other was dumping in Cassandra, right? So we need to connect these dots, for instance. We need to track the dependencies as well. Okay, so this data is actually generated by this notebook and so on and so forth, and this service is actually serving the data from the other notebook. So this tracking system has to happen, and then we need to scale. Need to scale both the jobs and the services. This is very important. Otherwise, you cannot. The job normally should be good enough to scale, but still, you need to think it like this. And the services has to scale as well. So you need to have a cluster maybe dedicated to that can connect to the different things. So what we do? We go from the notebooks, of course, and we generate an SBT project, SBT/Maven/Leningen/whatever. It's just a build tool, right? Then we produce a jar, which is important part. Then, around that, we create a Docker image and a marathon. So who knows Mesos, for instance, here? Okay, a few. So Mesos is just a cluster manager, right? You just nodes, right, and manage it for you, roughly. And then you have a marathon. It's a API on top. It's a tool that it can be can access the cluster and take care of the job. So it deploys it on node and keep it alive. If it fails, it redeploys it. That's just basically that, right? So we deploy that in Marathon. That means that from the notebook system, boom, we deploy the job directly. So you don't have to ask, ops guy to know, hey man, where is the Marathon? What is the structure of the JSON file and I have to structure in order to be to have my job there? Hey, how do I create a Docker? The analyst doesn't have to ask the data engineer, hey, how do I create an SBT project or a Maven project? You don't have to do that because the stubs are all generated for you. How does it look like? I mean, you have just some cells. Right. So this is just fucked up. There you go. So afterwards, we have the problem that we need to create the services. And again, you are in front of your notebook, you need to you just generated some data in Cassandra, and now you have to create a service. But it's not your really job. You don't really care how to create this kind of job. You just created the model, right? So what we do for you is just we create the stub for you, again. But because we know actually that you dumped your data in Cassandra or you read it from HDFS Parquet, we can connect the dots ourselves. So that means that we generate an SBT project with the driver to Cassandra, or that loads the machine learning model, or has already the different structure from the Parquet file already loaded in it. So you can just read the data without having to do anything. You just use plain connection and objects. So it's very, very easy. And by the way, we generate Avro onto these different schemas. So we take the machine learning model, the different Cassandra model, and we generate an Avro layer on that. So everything is typed in binary. Next, I'm gonna hit them quickly. From the notebook, we also, we generate Avro, we generate services. So we generate also the different services, as I said, that can go into Marathon. So we can just deploy them on Marathon and scale it up and down. Since we have Avro, we know the types. That means that we can rather easily, create the connectors that can read the information from Tableau and render it easily and beautifully, or ClickView or D3 ourselves. Right. So we have all this information available. We have a notebook. I can show it afterwards. You have a bit of time. A notebook that has markdown, text, code, data sources linked into them, outputs, things, services, Avro schema. So everything is around the notebook. That means that we have a shit of information out there, right? We have a lot of information available out there, right? So, I mean, we should reuse that. And we really should reuse that. So what we can do is maybe put that into Elasticsearch, for instance. Take the whole bunch of information and try to index everything with a bit of smart processes, try to link things all together. Okay, this sources has been used with this model, and this model has been stacked or assembled with this other model, and we had this kind of accuracy, and then we dumped it into this Cassandra table this way, and we had this schema. So there is a lot of things that we can do. We can infer, we can run inductive process on that. So that means that we can put everything in there and discover information. So concretely, what we can do with this kind of distributed data science pipeline you're in front of your new project, data science oriented, right? The customer asks you to maybe, do some variant analysis. So in genetics, you have genes, very long sequence of SETG. Okay, very, very long. I mean, really long. Say million of entries for one row, of course. So in these sequences, in a population, there is a lot of information which is shared. So in a population, there is a few positions in the genes which are varying, right? That means that this is the information that you want to take care about when you are doing an analysis to discover some drugs, impact or whatsoever. So you take this information, right, and you want to do some analysis on that. However, where are they? Where are those variants? Where are this information? Where are the files? I don't know. So you want to ask the system, okay, where are they? These guys say, okay, hey, there is a service for that. I mean, there is plenty of services that serve this kind of information, right? So discover that, and you say, okay, this is the endpoint that you want to use. So you load that in the notebook. And since it's a schema, you get the schema, you know how to use it. It's like soap. Who used soap here? Really? I mean, don't be shy. I mean, I know soap, right? It's not, it's not interesting, but still. Okay, so web services, WSDL whatsoever. So we have the information, what is an operation, what is a method, what is in a request, a response, a error whatsoever, what is the protocol to exchange the data, and actually we have the same information with Avro. So we get the schema, we can generate, we have the API to access it, so we just have to tab in the notebooks in order to discover what kind of method we can use and what are the different models that we can build in order to create requests on the system and what kind of response we have. So everything is streamlined. You don't have to do much. Okay, so you had this data, you process the data, and you say, maybe it's not exactly what I want. So maybe I want to go further, or maybe I want to check my data, because finally, man, I'm dealing with life there. I mean, this is variant method. I want to administer some medicines to some people. I don't want to mess this around, right? So let's check first from where this data is coming from, right? So here I can just check the notebook. I have the code. I have the metadata. I have the text. I have everything. I can read this. It's not just code. It's just a very documented code that has generated an SBT, jar, whatever there behind, but still, you have this information. You can read it. And you can say, okay, finally, it looks not that bad. So, but where is this information done? Where is the information accessed by the Avro service? It's in Cassandra. Okay, let's check in Cassandra. So I can load the Cassandra tables directly in notebooks and check what's going on out there. Okay, so you can play a bit with the tables, you can see what's in there, if they have the exact accuracy, if the elimination process of the features and so on hasn't ditched too much information, so you can read this information back from Cassandra. And maybe at that time only you say, damn, it's not exactly what I wanted. The process looks good, but actually it doesn't take into account all the sources I wanted, or maybe it ditched too many variance because it didn't took the full population. Maybe it took a portion of the population. So I don't want to just use this information. I want to go beyond that. And then you just copy the notebooks and you tune it. You tune it. You just have to tune it, right? It makes another notebook linked with the previous one, but still it's a new notebook. It's a new job. It's a new generation process. And then you can run the job on the process on the cluster. You have your new data set in Cassandra, and then finally you can start your data process on the first problem that you had. It looks like yak shaving, the thing that we do every day, right? But at least the system can drive you. And just cool, 12 minutes. So this is all I get right now. But because I may do a bit of show of the notebook if I'm asked for, but actually there are several things that I want to mention. So first, you can follow us, for sure, on Twitter. So there is a handle DataFellas, but also Xavier and myself, Nutsab, are on Twitter. The Spy Notebook has its own Twitter account. We wrote a blog at TypeSafe about this kind of philosophy and architecture. And by the way, in March 16, we'll give a online training. O'Reilly proposed us to host it. So at O'Reilly, we'll give an online training on chaining all these tools together, from Mesos to Cassandra, to do some data science pipeline, right, yourself, using the right tools. So if you want to join us, there is a form. Actually, like this. Actually, it's just a form to get notified about what's going on there, when it will happen. It's going to be the 3 and 4th March, 3 to 5 March, by the way. It's not really committing, of course. It's just asking for some information about the course if you are interested in. But we are very excited about this online training with O'Reilly. A great editor, by the way. There is this. Yeah, is it still? Yeah, this GitHub repository for a Spy Notebook if you want to check out. Since Spark is very shitty at versions, there is a website that can generate the right package for you, so you don't have to yourself clone the GitHub repository and then make distribution passing all the fancy parameters it requires to have your right versions in there. It's just a ugly form, by the way, but very helpful, because I have quite a lot of people that generated their own version. As you can see, is very crappy at distribution, so I had to do that. Otherwise, I would have to create them myself. It would take ages. And there is a good website that I just started, a few months ago, by the way, noetl.org, who relates why ETL is not relevant anymore. I recommend you to go there to check it out. There are a lot of information interesting. There are a lot of people that are writing in there. So people from Confluent, from Databricks, and from Nitro, and so on and so forth. And we have been proposed to write in there as well. So we will probably soon write our ideas about that very soon. There is, sadly, I didn't put the URL there, but there is also a data science manifesto that you might want to check. Has been initiated by a buddy in London that works at Barclay, that tries to dictate or to propose ideas or thought about how to be more agile and the way we are dealing with data, and even in a distributed manner. So it's just a manifesto like the others. So yeah, so 8 minutes is fine. So I'm done, and I'm open for any questions, if there are, about anything. Even demo if you like. Or beers. Not now, maybe. Hi. Nobody? Cool. So I guess I'm done.